Can everybody hear me? You can hear me without this, but yeah. Well, FCTV I don't think can. So, good evening and welcome to a presentation on the Coonamessett River Restoration Project. My name's Betsy Gladfelter. I was project coordinator for the lower river, which was completed. Construction was completed in 2020. Restoration will take place over the next hundreds of years. And I'm coordinator of the upper river with Mark Kaspersick, who's in the back. You want to just give us stand up, Mark? And you'll hear from Mark at the end of the meeting. He's going to recruit some of you for a project. So any restoration project has to do with eliminating or mitigating for stressors. So I'm very briefly going to explain to you what was done, and then for the second part of the talk, which is the upper river, Nick Nelson, who's our fluvial geomorphologist, he's the one who designs these projects, will give you a lot more detail about why these things are done. But the three things that were done in the lower river, let's see if I can get this to work. Yeah. So a mile of the lower river was restored starting in 2017. The first phase was done in 2018. The second phase of it was done from 2019 to 2020. And basically, barriers that were across the river, John Parker Road, Middle Dam, Lower Dam, were removed. Basically, the whole floodplain was opened. The second thing was the river itself was made narrower, deeper, longer, about 133% as long, with a variety of habitats: fast-flowing, slow-flowing, deep water, shallow water. And then the surface of the floodplain, due to the cranberry farming, had 1 to 2 feet of sand on it. That's part of cranberry farming. That was removed, put in borrow pits to the side, and the surface was made into, and you can sort of see it here, into what is called a pit and mound topography, so that everybody knows about sun plants and shade plants. Well, there are also plants that like their feet in the water all the time, and plants that like to stay a little drier. So all of these actions favor biodiversity. So our goals in these projects, so let me just, here's Coonamessett Pond, here's Great Pond, here's Vineyard Sound. This is the Coonamessett River Restoration Project. This is the Upper Coonamessett Wetland Complex. And the goals of these projects are to establish a healthy, self-sustaining ecosystem that supports the diversity of plants and animals. This also increases coastal resiliency by creating connectivity of floodplain and improving water quality. And we also want to increase educational and recreational opportunities. These projects started as fish passage projects. These rivers are diadromous fish streams, which means the diadromous fish spend, depending on the species, spend part of their life, all diadromous fish spend part of their life cycle in marine and part in fresh water. Most of them spend most of their life in marine and come to reproduce in fresh water. The one that's opposite is the American eel, which lives as an adult in fresh water and goes out to marine once in its lifetime to reproduce. So part of this project was to study what's happening with these populations, how effective we've been in meeting some of these goals. And a major part of today, and the first part, will be how have we done, what have we done, and what have some of the results been. The second part, and several people from Coonamessett River Trust will be giving that presentation. The second part is what's being planned for the upper river, and Nick Nelson will be giving that. Okay, I say these are, it takes a village to raise a kid, it takes a village to do a project, but it takes a village, it takes the state, it takes the federal government. And so we had over 40 partners for this project, and we had hundreds of individuals in town, including, this is, oops, excuse me. This sign, which is at Dexter's River, is a product of, well, it was envisioned by our high school art teacher, but it was done by, the background was her senior high school students, but the fish are all done by second graders. So lots of people have contributed to this. Just to give you an example, this is for those of you who know the river, this is Dexter's Crossing. So the water stewards asked if they could put a bubbler, and I said, this is a good place, everybody passes this area. The bike committee wanted to put a bike rack. This is an individual who's with the 300 committee, but it's an individual person who said, can I put a poop bag, dispenser, and a collection there? I will do all the collection. So this is fantastic. This is Coonamessett River Trust, the two not-for-profits who really got this project started, and without which we wouldn't have been as successful as we were, was Coonamessett River Trust and the 300 committee. So this is a Coonamessett River Trust kiosk. This is to show our all-accessible trail, which was paid for by the 300 committee. And this just is an example of, I had some extra grant funds, and I wrote and I said, well, actually, we've had so many contributors. There are 5 of us who put together all the interpretive signs. I said, but so we didn't have to hire somebody else. We have this extra money, can I use it for safety fences? And so you'll see safety fences on all the parking areas. So it's really been so those are the people who did the interpretive signs. This is Chris Bennett from DPW, and here's Mark, and here's George Patello when we put in the signs, and here's the AmeriCorps who also helped us put in signs. So this is another group of second graders, another year. But you'll see some of the people. Here's Linda, who's going to be talking soon, tagging fish. She also has this picture. We love this picture. And I just wanted to show you, this is AmeriCorps helping with invasives. And these 2 pictures show this is a bridge being built by Eagle Scouts, and this is a bridge that was built by Eagle Scouts and used by people who need it. And for the upper river restoration, we've been in the planning phase for a couple of years. We invited the people who were potential funders, and also Coonamessett River Trust, the 300 committee. There's Nick. Here's Division of Ecological Restoration, who plays an important role. Here's, again, Chris from engineering, DPW, and others. So a lot goes into the preparation of this, and you'll see where we are with this part of the project. So our first speaker tonight, you ready? Yeah. Is Chris Neal from, and I'm going to say from Coonamessett River Trust.
Sure, yeah. Well, thanks, Betsy. So thanks. Let me just get my talk up here. So this is great because I haven't had an opportunity before to talk about vegetation restoration, which is a major objective of these cranberry bog rehabilitation restoration projects. I have been involved through the Coonamessett River Trust and where my place of employment at the Woodwell Climate Research Center in town on a study that follows the patterns of vegetation from pre-restoration to the current time on the Coonamessett River. We're also involved with DER. I have a small project with them to track this on other bogs that are being restored around the southeastern part of the state. So I'm going to talk a little bit about how this project compares with those because I think it provides some insight into what we should expect when we move forward, if we move forward on the Upper River project. This has been a collaboration with Sarah Kleonsky, who's at UConn, who's doing her PhD thesis on bog restoration aspects, and Anna Pulak at the Woodwell Climate Research Center. So my goal with you tonight is very simple. It's to describe the processes and patterns that take place when you go from the raw restoration surface, which, as Betsy mentioned, is dug up to remove the sand, which is a legacy of cranberry farming, to remove the absolutely flat topography that exists in cranberry bogs, to control water, to control flooding for farming, and move towards a situation where you have more microtopography. And that microtopography is put there to encourage a diversity of plant and animal responses. I'm going to talk about the plant responses on the surface. I'm not so much going to talk about the river channel. I'm going to leave that to Linda in the next talk. Aspects of the restoration involve making the microtopography, placing some woody debris, reconfigurations to the stream channel, but also sort of minimal seeding of the old bog surface. And the questions I want to answer with you tonight are the following. Where do the recolonizing plants come from? What are the changes that occur in plant diversity? Because one of the goals is to increase biological diversity, as Betsy said. What are the proportions of native versus non-native species, right? This is important. Old agricultural areas tend to be potential places for colonization by non-native or invasive species. These are old farms. What patterns should we expect and why? What proportions of plants that colonize these sites are wetland plants? Because we talk about these as wetland restoration experiments. We're interested to know, are we successfully getting wetland plants into these restoration areas? And then a little bit of insight through some other work that we've done far afield from the Coonamessett in southeastern Mass is what would have happened without restoration? So what would happen if you didn't go in and do an active restoration, but instead just kind of let nature take its course? All right, so what did we do? We set out a whole bunch of plant plots in the lower, the middle, and what we call the upper or the reservoir bog on the Coonamessett. As Betsy mentioned, the lower bog was restored between October 2017 and April 2018. So we studied that pre-restoration and then through 2022. We're ongoing. We're still trying to keep up with monitoring that every year. And the middle and reservoirs restored in October 2019 to April 2020. So 2018 and 2019, we measured plots, and then starting in summer 2020 through 22, we studied the responses. We have 40 plant plots in the lower bog, 40 combined in middle and reservoir bogs. They're located in stratified but randomized locations throughout. We have permanent plot markers, and they're all 3 by 3 meters in size. So our method is we go out to all these plots, we assemble a whole bunch of botanical experts. I've become a botanical expert on restored bogs through this project, but we enlisted people like Pam Poloni from Falmouth, the late Don Shaw from Brewster, one of the region's expert botanists, Mike Whittemore, a botanist on the vineyard, and Sarah Boyce, a botanist from Nantucket. We ID every plant species in those plots. We put the plot in exactly the same location every year. We estimate the cover of every species, and we classify species as to whether they're native or non-native, what their life form is, whether they're a forb, that is a wildflower, a broadleaf plant, a grass, or a rush, or a sedge, and whether it's a tree or a shrub, and its wetland status, whether or not it grows only in wetlands, it grows as well as in wetlands as in uplands, or it just grows in uplands. Again, the aim is to get wetland species in there. All right. So let me talk about what we found, sort of in a nutshell summarized. All the seeds that come in, except for very, very small areas that were seeded along the roads and along the immediate stream bank right after the restoration, came from buried seeds in the soil in that old bog. When you dig up that surface, it exposes seeds that have been buried there for years to decades. And those seeds are incredibly diverse, and they explode and germinate after that surface is exposed. They were there to begin with. And this is sort of what you get in the first year after that sort of mud surface is created. So that seed bank is diverse, and it's in all these bogs. So it's really kind of a natural process that recolonizes from an existing stock of native seed. That occurs both in the wetter spots and in the drier spots. That was a shot of a wetter spot. This is a shot of a drier spot. And you get a whole variety of things that come in. And some of them were not in the flora to any significant degree before the restoration, right? They were there, present in the flora only as seeds. A couple of examples of those plants, for example, are these things like eastern blue-eyed grass, and that is usually in wetlands, but can grow in a place like the picture I just showed, and lance-leaf violet, which grows exclusively in wetlands. And if you go out there in the spring, when these are blooming, there are still large numbers of lance-leaf violet. Very interesting plant. It seems to be one of those species that responds to these disturbances in these situations. So let's talk about diversity, right? Here's just for the lower bog. Before restoration, in all of our 40 plots, we found 81 species of plants. That's actually a pretty diverse flora for an area the size of the lower bog. After restoration in 2018, that went up to 104 species, went up to 119, and now it's kind of stabilizing around 105 to 110 species. So a big increase in the total number of species that you can find if you go out and search or quantify this in plots, right? But if you look at the diversity sort of per unit area, the diversity per plot, you get an even bigger increase. So just look at these dark green bars for the moment. These are the native plant species. So we went in the lower bog pre-restoration from about 13 native species to 28, right? And what you see by looking at these little green spots up here is there are just a few non-native species that come in, right? There were actually, just a handful, one or two non-native species per plot. These are just really common garden weeds that are sort of everywhere in the landscape. They don't hang around for a long period of time. But the flora that responds is overwhelmingly native plants. And we can look at it by sort of numbers of species, right? These are 37 species in every three, on average, in every 3 by 3 meter plot. So that's a great plant diversity. If you look at the cover, the area covered by these native, by all of the plant species, you can see that it was high because this includes cranberries before restoration, and it can be above 150, it can be more than 100% cover because plants have layers, so we're counting each layer of plants, right? And the coverage is going up, right? The ground, after restoration, the ground is being colonized, but the non-native cover is very, very small. And that's absolutely characteristic of these restoration sites at the Coonamessett and other places. There's a large native seed bank. The low pH and the perennial nature of cranberry cultivation originally, the fact that it's not tilled, it leads to a predominance of native species. So unlike other old farm fields, say like at the Peterson Farm, you don't get a huge flush of non-native species coming in. So I think that's very good news, and that provides insight into what is going to happen in these other sites. The other thing is we've increased wetland species by a substantial amount. This is just the wetland species here, the number of wetland species. The per plot here was 37 number of species, but of those, 20 are wetland species. And that number has increased substantially from the pre-restoration condition. So that meets one of our main objectives, is to increase the coverage of wetland species and increase the number of wetland species. And the same thing happened. That was the lower bog. This is the middle bog. Same thing, a doubling or more of the cover and the richness, the diversity of wetland-dependent and wetland-requiring species. So those are all, and they were all there beforehand. So in summary, for this part of the results, recolonizing plants come from this large and remarkable seed bank. Plant diversity increases sharply. Most of the plants that colonize are native species, and in fact, the non-native coverage and number of species go down with restoration. Wetlands and wetland plant species increase and predominate. All right. Whoop. So now I just want to say something about, whoops, how do I go back here? That this pattern occurs in other places. If you're interested to see another site that's analogous to Coonamessett, go to the Childs River on the Rod and Gun Club property and look at those restored wetlands, and they'll look an awful lot like the wetlands on the Coonamessett. Same species, same predominance of native species, and same predominance of wetland-dependent species. And if you go to Foothills Preserve in Plymouth, where we're also following the responses on the same timetable, it looks not exactly the same, but look, the patterns are very, very similar. So this is a predictable pattern in the landscape. We know what's going to happen. It's not going to be a surprise when we do a similar style of restoration project on the upper river system. And I just want to end by making one point about if we didn't do anything. And that's an option, and in fact, it's happened on a lot of bogs around the landscape in southeastern Mass. And so we went around to a whole bunch of sites, including some on the Coonamessett that weren't part of the active bog system through the early 2000s, but that got retired from farming different numbers of years ago. We compared them with some active farms, and we did the same survey of vegetation, and we just used different places in the landscape to represent different times since those farms were retired from active cultivation. And we found the same overall patterns, right? That is, that non-native species don't increase. These are bogs retired in 60 plus years ago. Bogs retired sort of 30 some odd years ago. Bogs retired for less than 10 years, 10 to 15 years, et cetera. And we see the same predominance of, across all these sites, high increase in native plants, a very small increase in non-native plants that goes along with that. So even when you don't dig it all up like that, you tend not to get a big invasion of non-native plants. You also get an increase in wetland plants. It's not as sharp and dramatic as you do with the active restoration, and you get a lot of sort of upland plants and these what we call facultative plants that can grow in, like red maple is a good example. It can grow in uplands or wetlands. And in fact, if you look at the vegetation patterns, I'm not going to show you all of the details, but the three real winners after decades of succession in retired but not actively restored cranberry bogs are pitch pine, sweet pepper bush, and red maple. And so you end up, and we see this again and again in multiple sites, you end up with sort of a woodland that looks like this. It's an altered woodland. It's full of native species, but it doesn't create the wetland values and the wetland habitat that is really a target of the active restoration. So that, this is from Red Brook up in Bourne, but you can still see the legacy of the farming under there, the ditches, the flat terrain, the very sandy soils. But that sandy soil makes it hard for the wetland plants to colonize and maintain, a foothold in there. There are some there, they're in the ditches, they're in other places, but you really lose out in terms of the whole, creating a wetland at the landscape scale. So I'm also giving the next talk, so I'm gonna pause there and maybe take any questions about the plants before I jump into the nutrient removal dynamics.
Chris, I'd rather have people just keep going on.
Oh, you want to keep going?
Yeah.
Oh, okay, okay. All right. Oh, and you have questions? Okay. All right. So I'm going to give the next talk, and it's done with a different set of partners. These are Casey Kennedy at the Cranberry Station and Linda Deegan at the Coonamessett River Trust. Linda's at Woodwell. You'll hear her in a minute. And we've been monitoring the nitrogen dynamics of the Coonamessett River since the restoration of the lower bog unit. We've had funding from the town of Falmouth and other sources to do this. Of course, the town of Falmouth right now, the Water Quality Management Committee is very interested in the nitrogen dynamics of this watershed because they're actively trying to construct a plan to address the nitrogen problem in the watershed that contributes nitrogen to Great Pond. So, if the restoration has a role in reducing nitrogen to the Great Pond, that's of great interest, and we want to understand what that role is and how we might potentially even enhance it. So just what we did in terms of nutrient monitoring. This is now the best studied sort of Cranberry River ever. We monitored nitrogen concentrations upstream and downstream twice monthly for 4 years with hardly a miss in there, hardly a weekend that Linda and I didn't go out there and grab water samples. We just recently, we had worked with the town and the Conservation Commission to get permission to install deep groundwater wells on both sides of the river, because one of the big unknowns is how much groundwater is coming in and how much nitrogen is that delivering to the river. So we installed 3 deep groundwater wells that measure every 5 to 10 feet going down to 100 feet. And then we used both the incoming groundwater and flow and nitrogen measurements upstream and downstream of restored wetlands in the lower section to estimate the nitrogen uptake by those restored wetlands. So here's what we did. We sampled all these places up and down the Coonamessett River. This is the outlet to the pond. This comes down to River Bend at Sandwich Road. This is the upper river system that Nick is going to be talking about. Then down, here's Pond 14. We measured the bypass, the outlet, Parker Road going down. Here's Dexter, and here's Route 28. I'm going to talk some about Route 28. I'm just saying these are different distances from the pond, so I can draw a graph of change in concentration by distance downstream from 0 meters up here at Coonamessett Pond. The other thing we did is we've been measuring flow at the outlet of the river at Dexter since 2006. I'm just going to talk about the period of 2018 to 22 where we have nutrient data to go with it. But there's a flow gauge at the bottom with a sensor that records the river level, and from that level with some smoothing, because now you'll see that it's influenced by tides down here, we can calculate the flow of water out, and with the flow we can calculate the nitrogen that's going out. All right, so our groundwater sampling is this. Here's where the wells are. You can see them. They look like this. They're in these blue cases. Inside that, we have a lock on it so nobody can mess with it, but this has this octopus of colored tubes. Each color corresponds to a different depth. So we go out there with a pump and we can pull water from the different depths and measure the concentrations at different depths. So I'm going to also talk about nitrogen balance in the lower river. These are the folks, Kaya Billings and Madison Griffith, who worked on this over the last year. We actually sort of looked at the flow in these little creeks that were built to keep water cool and provide trout habitat at their mouths, but we're interested in them as nitrogen removal zones. And so I'm going to talk about those creeks and then the other way that nitrogen gets removed as it seeps into the river. And this is just one of those creeks, whoops, that comes in. Whoop. I was going to get my animation there. This sort of up from where it wells, this is a place where the water wells up out of the ground, and here's where it sort of meets the main river. And we can, by measuring temperature in here, we know sort of exactly where that groundwater is upwelling if we measure temperature in the summer. So we know water upwells here, and then by following the concentration as it goes downstream, we can estimate the removal that occurs in those little features that were part of the restoration design. So the other way we measured nitrogen balance in the lower river was we just measure water in and nitrogen in at the top. We did this for Swift Bridge here, down to the Dexter Bridge. We know the concentration in the incoming groundwater from the wells, and we can look at the concentration that we see in the upwelling water, and we can balance the mass of nitrogen coming in sort of in the upper channel here into this reach, out of this reach, but also entering from one side here, or entering by bubbling up through the ground into the main channel, which was very hard to measure, but we can get that by difference, just by knowing how much water flows in here, and it has to flow out here. There's no other outlet. So I'll present that balance. Right? So one of the features of the Coonamessett River that doesn't occur in all cranberry rivers, but is true here, and I think bodes well for this site as a nitrogen removal site, is that the concentration of nitrate, that's the mobile form of nitrogen that your septic waste in the ground ends up as and then travels to the coast, increases as you go downstream in the Coonamessett River. And that is true in the summer, it's true in winter dates. I'm just showing 2 of the 20 some odd dates per year that we collected. And it ends up at a fairly high concentration at the bottom, and that is sort of half to 1 milligram per liter, or 35 to 70 micromoles per liter. And that's true in this year. It's true in every year. It's true in most seasons of all the years. This river is picking up nitrate coming in from the developed portions of the watershed. The upper reaches are less developed, more wooded. The lower reaches have all these houses in the lower watershed. And that nitrate comes in and ends up going out at Route 28, and that concentration is actually, sort of steadily increases. The concentrations of the other forms of nitrogen that are less that are less tied directly to what's going out of septic tanks and fertilizer runoff from the watershed don't change nearly as much, and they're on the whole much lower. So the action is in the nitrate in this river, especially at the lower end. This is ammonium, very low. Dissolved organic nitrogen, a little bit higher, but no upstream, downstream pattern. And particulates. This river, if you go out there, it's very clear, runs clear all year long, doesn't have a lot of particulates, and so that remains low, and it doesn't change sampling to sampling or year to year. So the action is in the nitrate, right? Okay, so just to show you that we measured flow and that the flow has changed, the pattern of flow has changed with restoration. This is just the discharge calculated from the level of the river. And what do you see here up to 2013? You see that every so often, several times a year, the discharge went to near zero. That was the grower putting boards in the river, stopping the flow to use water for the bogs. When the growing went away, that went away, and now you have a more naturalized system. You had restoration here, and then you had these very high spikes following restoration. Turns out that those, and Betsy's heard this story before, but those spikes were now, with the removal of the lower dam, those spikes were high tides, like last week, coming into the lower end of the Coonamessett and pushing up. So the floodplain has been more connected by the dam removal, and you get these high tides, nor'easters, and storms like we've had sometimes, pushing water up. So these are really not flow increases, so it made our life harder because now we have to filter those out of our record. but it's possible to do that, and it provided some insight into the fact that the restoration had restored conductivity. What having the flow data, though, allows us to do is calculate the total amount of nitrate and nitrogen, total nitrogen, that's going out the mouth of the river. And we've done that for the years for which we have full records now. And the nitrate makes up the bulk of that, so it's 8,000 to 12,000 kilograms going out, of nitrate versus, somewhat more, but predominantly nitrate in the flux. What's interesting about this, and I presented this to the Water Quality Management Committee a few weeks ago, is that the Mass Estuaries Project, on which the watershed management nitrogen removal numbers and strategies need to be based, was measured by Brian Howes back in 2003, 2004 as a much lower number than we're seeing now. So this export has gone up substantially in the interim. So it makes the nitrogen removal overall harder. So one of the great things about the restoration is it occurs now in this zone of high nitrate input. So the inputs are coming in where the restored wetlands are. And so that makes it very plausible that the wetlands are now potentially intercepting some of that nitrogen. All right, I've got to speed up. I'm going to skip over that. So one of the things that I think Linda's going to touch on in a minute is that we see much more variation of the nitrate concentration in summer than winter. Much lower concentrations in summer than we see in winter. That was the last graph, was just sort of the annual pattern of that. Why is that? Well, that's because in the summer, that channel is filled with vegetation. A naturalized channel is now filled with bordering and submersed vegetation. That vegetation is taking up nitrate in the summer and acting as a sponge for that nitrate, preventing it from moving downstream. In the winter, when that sponge isn't there or decreased in its uptake rate because of temperature and dieback, more of the nitrate that's coming in the watershed is actually making it out the bottom. So, and this is just a picture. Here's your channel. One could imagine lots of nitrate uptake occurring in that vegetated and as Betsy talked about, complexified channel, right, due to the restoration. So that's another ecosystem service being provided by that. Whoops. I have to skip over that. All right, just to touch on the groundwater wells and the nitrogen balance, because it has a good story that it ends with. Is we just discovered this. Nitrate concentrations peak in these wells between 20 and 60 feet, right? And it's very, very high concentrations. Like, this is the concentration here that's coming out of the wastewater treatment plant, and which is a good functioning plant, but nevertheless, this is even higher. So there's a lot of nitrate coming in from the watershed on both sides of this river. And we have used that to look at the input to these channels, and we've figured out that we can calculate using the concentration and the flow rate of water in these channels that we get nitrogen in, nitrogen out. So we can calculate uptake in these channels that ranges from 40 to almost 80% of the nitrogen that flows in from the groundwater that bubbles up in these channels is taken out by the time that water traverses that small tributary that's kind of replaced the old bog ditches and makes its way into the river. So that's good. They're functioning as habitat, but they're also functioning as nitrogen removal zones. So about half of nitrate is removed in those small creeks. All right, so now I just want to calculate what's removed in the lower river. We calculated that in the fall of this year, the flow of the river doubled between Swift Bridge and Dexter Bridge. There's a huge input of groundwater in that very lower section of the river. We calculated that 78 milligrams of nitrogen per second came in, 152 went out, but based on that high concentration in the groundwater, right, we calculated that 301 milligrams per liter were coming in. So 301 total. Of that, most is in groundwater, because only 78 of the 300 is coming in, is flowing in the top, right? That means that leaves over a loss of 149 that is no longer accounted for. That is either lost as denitrification, which is a great thing, or it's taken up in the vegetation. So again, no matter how you calculate it, well, that ends up being 4,700 kilograms a year if you extrapolate that out. That's a very large number based on the total export of 8 to 12,000, right? That export would be way, way greater if that interception wasn't occurring, right? And about half of the nitrate coming in the groundwater is removed in the lower river. So this is partly a function of where this wetland is in the river. Like, we would not expect that extent of nitrogen removal in the upper river because the upper river has lower concentrations to begin with. But I think it's a great example of how a wetland can perform this function that the town is contemplating spending millions and millions of dollars to address with other engineering ways. We can, by restoration and nurturing naturalness in our watersheds, we can provide a service that then also saves us some money. So, all right. So I'm going to thank you, and I'm going to turn it over to Linda.
Well, good evening, everybody. I'm Linda Deegan, and I am a research scientist at the Woodwell Climate Research Center, as Chris mentioned before. And yes, I like nitrogen, but I like nitrogen actually primarily because I care about fish. And this is a picture of me when I was 10. I've cared about fish for a very long time. And I am really blessed to be able to express that enthusiasm for fish by working with the Coonamessett River Trust and also through my job at the Woodwell Climate Research Center. So I'm going to tell you two fish tales, if you will. I'm going to talk a little bit about the work we've done with river herring, and I'm going to talk to you about the work that Steve Hurley, that man in the back there, one of my heroes, has done with brook trout in the Coonamessett. And I'll give you a spoiler alert. All of this that we've done to the Coonamessett has helped. The fish are responding. We're finding new fish in places we never saw them before because we've increased the connectivity. We're seeing higher abundances of certain fish. And, you know, it's just all for the good. So as you've heard, you know, there were two really fundamental things wrong with the Coonamessett prior to the restoration. One is that the aquatic habitat in the river was really poor. This is an underwater shot that I took of the lower Coonamessett before restoration. It had no underwater structure. It had no plants along the sides of the river. It was really just kind of a sandy barren for the most part. And so there wasn't a lot there for fish to eat, and there wasn't a lot there to protect them from bird predators. So there was lots of sand and really not much else. And you've seen the pictures that Betsy has shown. You saw the ones that Chris showed. Clearly, the structure in that river and along the sides of the river have been changed by the restoration dramatically, and that's all been to the good. The other big issue is the connectivity of this river, right? So fish need to swim from the ocean up to the lake. You can see they're just kind of stuck in this culvert, trying their best to get through, but they can't. The water velocity is too fast. The fish are just kind of hanging there because they can't make it through. And some of them never make it through, and some of them try and turn around and go back to the ocean. So there were over 26 culverts or dams in less than 4 miles of this river. And the thing that the restoration is trying to do is get rid of every single culvert that we can. Turn them into open river bottoms so the fish and actually other animals like turtles and river otters and other animals have a shot at just going up and down that river without having to get out and cross over a road and get to the other side. Not really an option for fish, so we're really focusing on the culverts. So I'm going to tell you again about river herring. you know, this is a shot here of a school of river herring in the river as they're sort of waiting, holding, staging to migrate upriver. Herring are a really critical part of the food webs in these systems. And I'm sure, you know, some of you can remember that not that long ago, you could go to the river and see this kind of sight pretty often, and now it's pretty rare. It's rare in almost all of our rivers in Massachusetts that have herring runs. All of the herring runs across all of the runs in Massachusetts are quite diminished. And that's a combination of things that are happening out in the open ocean, overfishing, probably climate change, some food web things, maybe overpredation out there by other organisms, but also a lot of changes to their freshwater spawning and rearing habitat. So the part that we're trying to do in the Coonamessett is fix that freshwater part of the end, and working with other people to hopefully help out on the marine end as well. And again, we care about herring because they're really of both cultural and ecological significance. They are the center of a huge food web that reaches out into the open ocean and feeds striped bass, actually feeds Atlantic cod. They also, inshore, support ospreys. I'm sure, how many of you have seen an osprey flying off with, exactly. And I don't begrudge the osprey a fish or two, but they need to have some restraint. They're also really important to freshwater otters. And, you know, historically in the past, they were part of our culture because they supplied food in the spring, a high protein food source in the spring, when not much else was out there. So they really play an important part in the food web that includes humans and the ocean and freshwater. So we'd like to see them come back to their former abundance if we can. So what do we do on the Coonamessett to think about herring? Well, we do two things. The first thing we do is count the number of herring that are migrating upstream. So how many of you are counters in either the Coonamessett or any other river? Yeah, that's a pretty good portion of people. What do? You go out on the Coonamessett at night, you stand, you look down, and for 5 minutes, you count every fish that swims by, right? And what's interesting is not only does that allow us to track sort of the annual run of the fish that are going upstream to spawn, but people are making amazing observations about how other parts of this river are recovering too. So we get these observations of increased sightings of muskrats and lots of increased sightings of ducks, and you know, just lots of swallows and spring peepers, sounds that we haven't been heard for a long time along the Coonamessett. Now clearly the herring are highly variable in their abundance in every river all the time. And we saw a lovely increase in the 2013 through 2016 here that made us all like very excited about the return of herring to the food web. And then something has happened to where they've sort of crashed. And how many of you counted last year in 2022? How many of you actually saw a fish in 2022? Yeah, the count on the Coonamessett, and indeed the count on many of the rivers on the Cape, was very, very low in 2022. And Mass Division of Marine Fisheries is still trying to figure out, you know, why, and we want to really see what's going to happen in 2023. We were in 2022 back to the kind of counts that we saw when we first started working on the Coonamessett River restoration. Clearly, you know, the whole world has work to do if we're going to keep herring functioning. But our job is to do the best we can with their migration corridor and their freshwater spawning and rearing habitat. So that's what we're working on the Coonamessett restoration. So how do we know what to do? How do we know what to restore? Well, that's where we do the other thing on the Coonamessett, is we tag herring. And we use a really small tag called a pit tag, and I'm just going to have you guys pass these around. You look inside this big fish, you'll see there's a little tag embedded right there. This is more or less the right size for a herring. And that tag operates like Easy Pass on the highway. You know, when you drive underneath, it's the exact same technology. It's easy pass on the highway, or you know those machines you have to walk through when you leave a high-end electronics store to make sure you're not stealing anything? Same technology, only we use it for fish. I use it for herring, and Steve uses it for brook trout. So what we do in the spring is we implant one of these little tags here into the fish as they're moving upstream, and then they swim through our Easy Pass detectors here. And we have the Easy Pass detectors put at critical locations up and down the river. And based on this information, so this is an example here of where we tag them down here at the bottom of the river as they're moving up. These red bars are where we put antennas, and we move them around in different years. This was a year when we tried to look at one of the culverts, the ones that go under John Parker Road, that we've now, because of this information, gotten replaced with an open bottom bridge over the river, so the herring can move easily, the trout can move easily, and other mammals can move easily without having to cross over the road or not get through. So this is what we call a sort of perfect track for an alewife anyway. It's going up the river, gets to Coonamessett Pond, stays there for a while, and then turns around and comes back. That's the right thing to have happen for an alewife. And one of the things that we learned about the fish in the Coonamessett from this kind of work that we probably wouldn't have otherwise known is that our fish migrate at night. And this is in contrast to a lot of other herring runs where the fish move during the day. Now, why do they move at night? Well, we got a couple other things that help us figure that out based on the tagging. So just keep that in mind. They're moving at night, dawn and dusk, and hunkering down during the day. The other thing that we learned, and this one wasn't so much of a surprise, was that all of those culverts, the things that up and down, those 26 culverts in 4 miles of river that looked like this because they've been there for, I don't know, a century or so, were definitely causing them, they can get through, sometimes they can get through, but it takes them a while. So this is a tagging array where we see below the road crossing, that fish is just sitting there underneath one of our antennas here. They're moving this way up the river. They just sit here, trying to push through that culvert because the velocities were too high or the culvert was blocked, or any number of reasons. And as they sat right here, we always knew when they were hanging up behind that culvert because we just look out and count the number of ospreys and the number of gulls and the number of birds, nailing them. So it slowed them down, and in many cases stopped them altogether, and they just turned around and said, the heck with this, I'm going to go out to sea. Sometimes they go out to sea and turn around and go in another river that's a little bit better. But 7 times as many detections below that road crossing as above it. So that's not a good sign. So what we figured out, based on all of this information, and this information combined with the counting, is that the lack of stream edge vegetation, so this is a shot of the river before restoration, and the lack of in-stream protection here resulted in high predation on the herring. And again, the birds get some, but they can't have them all. And that delays in the culverts most likely increased predation on the herring. So all of this was contributing to the demise of herring, I guess, is how you'd put it. So we put all this together to help think about how to restore the river, and you've seen some of those pictures, right? So we've removed culverts, we've increased in-stream vegetation, in-stream structure, alongside the river structure, and all of that has been really good for herring, and it turns out it's been really good for brook trout. So one of the cool things that Steve shared with me recently, one of the things that some people don't know about the Coonamessett was that early on in the 1800s, the Coonamessett was a premier destination for people to drive down from Boston. There were actually leases on the Coonamessett for people to, they leased sections of the Coonamessett to go brook trout fishing because it has really strong sea-run brook trout population, which got extirpated in the early 1900s due to probably some overfishing, offshore mortality, changes to freshwater habitat. But Steve, who's been in charge of this, restored brook trout in 2013 to those upper reaches of the river above Sandwich Road, where there's still some vegetated cover, where the water was still coming in. It was pretty cool. It was pretty clean. By transplanting wild adults from the Mashpee River. In that upper section of the river, fish have been reproducing since 2014. So a year after he put them in there, they've been reproducing there. The cool thing is, great news, we have reproduction occurring in the lower Coonamessett. So these are some pictures that Steve shared with me from October of 2022. This is a male that he caught in the lower Coonamessett and a female. Spawning male, spawning female. Not only that, but we have volunteers that have seen young of the year. Actually, one of them caught a young of the year in his hands in the lower Coonamessett. And I would tell you where Steve caught these, but he told me if I told you, he'd have to kill you because we're trying to protect these sea run trout so they have a chance to spawn a couple of times and we can really get this population going. So in addition to those two, one really unexpected thing was we've seen new sea run species coming in. So moving upstream, sea run white perch, which had not been documented in the Coonamessett for I don't know how long, surprised us when we were out there sampling for fish. So a sea run white perch showed up in the lower Coonamessett about 2 years after we breached the lower dam, which Chris showed you with that increased hydrograph shows we were getting tidal input there. So very cool. Not only the two species we were trying to help, but a third one we hadn't even really thought a lot about. So for the first time in 200 years, we have really good connectivity. We replaced culverts that look like this with bridges that look like this that fish can get through. And we've done the tagging on this site here to show that before it was 7 times stopping them, and now they just blow right through that thing. We've also changed habitat from something that looked like this to places that look like this. So lots of places for fish to hide. One of our challenges has been those fish are getting really good at hiding, so we're having some trouble catching them these days, but we're good with that as long as the herring and the, as long as the seagulls and the, what's that bird? Osprey have trouble catching them too. So not only have we created a really good and better location for the fish in the system, but we've also created a fantastic outdoor classroom. And I'm going to turn over to Wendy to talk to you a little bit about what we do in terms of classroom education and outreach.
Hello. I'm Wendy Bissler. Oops, let me advance here to my thing. Is it better to do it with this or with the... Aha. So I'm president of the Coonamessett River Trust, and I'm going to tell you tonight about the educational outreach programs we've had over the past several years. In particular, 2 of them, the Adopt a Herring project and our school field trips. And this picture here, Betsy had told you about she had showed that mural that the kids of 2nd grade in T-Ticket had painted fish and put it on the mural that the art teacher and art students at the high school had put up. This is also another project that Jane Baker at the high school had done with the advanced placement art students at the high school. And what they did is they had the kids make these Japanese style fish kites that, that they are, sorry. Aha. These are these that they made that are supposed to be herring kites. And smartly, the teachers gave it to them at the end of the field trip, because otherwise they would have been playing with them the whole time. But you can see how excited they are, and the kids love going to these field trips on the river, and we have a very fun time hosting them there. So first off, the Adopt a Herring project. So actually, it was Linda who had the brilliant idea that we're gathering all this information from the fish that we're tagging. Wouldn't it be fun if we could allow people to adopt these tagged fish? So about 2015, we started making it available to the general public that they could adopt a fish. So you could name your fish, and you could watch its progress as it went through the Coonamessett River system. And then we realized, well, hey, this would be a great thing for kids to learn about. You know, why don't we make these available to the classrooms in Falmouth so they too can learn about the fish in the river? And we think it's just a really great way for people to feel a connection to what's happening in the river and a connection to what the fish are experiencing in the river. And it's been really great. So what you're seeing here are the tagged fish or the adopted fish that we gave to Miss Stevens' class at Mullen Hall. And here are the names that the kids gave their fish. And as usual, it's just a little bit, there's a Bubbles, fish named Bubbles. It seems to be one of the most popular names that the kids like to name their herring. But the great thing is the teachers can use this information in a lot of really interesting ways. Really creative teachers have found all kinds of fun things to do with this information. Some teachers have the kids write stories from the point of view of the fish going up the river and what kind of things they may encounter. You know, some teachers are talking about the differences, you know, how the difference is between the way the fish are moving through the system, and things like that. And so it's been really great. And also, of course, the kids are having a very big connection to their fish. You know, they're worried, oh my God, what's going to happen to my fish? You know, if they go and see an osprey carrying off a fish, they think, oh my God, is that my fish? Is that the fish being carried off? So we found this is really, so we started that in 2015. And then around 2017, we started hosting field trips. And we thought, well, if the kids are adopting their herring, they should come and see where their herring are living. So in 2017, we hosted a few classrooms. We had a couple of second grade at T-Ticket, and I think a few fourth grades. And then it's been rolling and gaining in popularity since then, so that now, this past year, we did all the fourth grades that are part of the Green Bus Tour. There's a Green Bus Tour in Falmouth that every spring they visit different sites in town that are associated with like either restoration, or last year the Sea Education met the kids on the beach and they did a beach cleanup, things like that. And then this year, this is the first time this spring, we hosted the fifth grades. And mainly, we hope eventually to break that up to do the spring field trip and a fall field trip. But this class of fifth graders never had the opportunity to go on the fourth grade trip because of COVID, because it had been canceled. But anyhow, you could see here that the kids love this, and we ended up doing 13 field trips last spring, which was quite a lot of work. We hosted over 518 students. If anybody's interested in helping, we would welcome your help, because it is a lot of work, but it's very much worth it. And I just want to put a plug in how great the Great Way Park has been for staging these field trips, because before, you know, the buses had to be on John Parker Road. The kids would get off and get on there, and you know, that road's very fast, the traffic's very fast, it can be dangerous. Well, now the bus can pull into the parking lot, the kids can get off here, they go down that path, and we have this amphitheater where they can sit, and we can give a little introduction about what they're going to see and about the history of the river. And here are some kids having their snacks, looking over that beautiful view over the river. And that's just, it's been really, really nice to have that. So, what are we talking about when we take the kids there? So we had come up, and I should say not we, but in particular Maureen Nolan, who's sitting over there, who's a retired teacher from Illinois, who we are very fortunate decided to retire in Falmouth, and has helped us develop this what we talk about when we go around the river. So each of these numbers here represent an area where we'll stop and talk about different aspects, either what they're looking at the river or the history of the river. So like here at number 19, we'll talk about, hey, look at, what do you see in the river there? I see something there. Look, there's a riffle. Why do you think they would have, the restoration people would have put a riffle in? So it kind of makes the kids kind of think about what's happening, what they're looking at. I mean, they always love the turtle pond, of course. And Lou Turner, his family, he passed away sadly last winter. His family has put a memorial bench here. We point that out because part of what the kids learn in 4th grade curriculum is they learn about stewardship and conservation land, and also what can they do personally to help improve things, and activism. And so we like to point to Lou Turner as an example of that. He was president of the Coonamessett River Trust. He was the one who really pushed to do the field trips for the students of Falmouth. And so we like to point out, like, Lou accomplished a lot for the town and for Falmouth and for the kids, and you're on this field trip right now because of Lou Turner. So, you know, that's just a nice thing we like to do. So things like that are pointed out on our walk around the lower part of the river. And so Maureen in particular thought the best way to approach this with the kids is have them think about this as investigative scientists. You know, they discuss how the former river had a lot of problems, then what does a healthy river ecosystem need? And then have them brainstorm is like, okay, how do we fix this? How do we make this into a more natural river system? And the amazing thing is the kids tend to pick or think about the things that actually occurred on the river. So, you know, it's a great way for them to get thinking about it. Part of what they do too is they all adopt a herring, and so they follow that. And something new that we did this year, if you want to pass these around, is we have this scavenger hunt. And this is pictures from local photographers in town of different birds and different things that we've done to the river to bring it back to a more natural system. And also these lovely, lovely drawings of plants that Maureen, again, the star here tonight, did. But of course, it's very funny. When you take the kids out there, some of them immediately see everything, you know. Oh, yeah, I see a bald eagle. Sure, that's... and, I'll go to an oak tree and I say, what kind of, hold up an oak leaf. Okay, what kind of plant is this? And the kids will say, a poison ivy? And it's like, oh, no. But, this shows the value of doing this, because some of these kids never get an opportunity to spend a lot of times outdoor. And when they're outdoors and they're in their own town looking at this beautiful, fabulous place, plus they're starting to learn to observe and look at nature around them. So it's been a great thing. So that's the 4th grade. Now 5th grade, the emphasis is a little different. So they look at the history of human impact on Earth's resources, and they look at wetland functions, and they also how changes in behavior can improve the environment or how to undo damage. I mean, what a perfect thing to come and look at the Coonamessett. It fits in perfectly with what they're studying already. So this year, we're thinking about spending more time in this area. It does take a long time to walk around this whole area when we're doing these field trips. So we want to make it a little bit more hands-on. So we're hoping to have the kids look at the plant biodiversity, look at the richness of the different species, look at invertebrates in the water, do some water chemistry, and actually with the herring tagging information, look at the data and do like graphs and stuff like that, because they're at that age when they start doing that. And this other fun thing that we did last year, but we have started, and again, this is Maureen's great idea, is it's called Marsh Metaphors. So we have a bag of thing with objects, different objects in them, such as like a strainer. So we asked the kids, and I'll ask you too, the strainer, how does a wetland work as a strainer? What kind of things does a wetland do like a strainer? Anybody? Anybody? Yeah, it filters things. So it can filter out nitrates, it can filter out, you know, any kind of other pollutants. Like here's a little pillow. So how do wetlands work as like a pillow? Pardon? Absorb? Well, also then, you know, what do you do with a pillow? Like rest. So wetlands are also a great place for birds, migrating birds, to take a break on their migration and rest a little bit. So this bag is filled with all kinds of interesting things like soap, because it helps clean water, a whisk, because sometimes it helps mix things up. So that's been a lot of fun to work with. And this is our most popular activity on our field trips. So each of these little plastic Easter eggs that you may be familiar with, they have one of the pit tags in them that we've put in the herring. We hand one of these to each of the kids. We have them drop them over on the bridge, and we have an antenna at one side. And when they drop it, and this way it demonstrates how the tagging works with the antenna.
2, 1, go!
So they drop it on one side, they run over to the other.
And there's one last one. Come on, little Harry. There it goes. There it goes. All right. Good job migrating, everybody.
So, again, it was just a lot of fun doing these field trips. These are some of the thank you notes we received over the years. It's great. And I just want to say one of our main goals is trying to get the kids to connect with nature in their own backyard, and also to realize that how improving and restoring this river had made things better not only for herring and trout and all the other critters that depend on it, but also for the people too who like to go there. And I know it's a very popular place to walk your dogs, and we know what other functions it's doing, like helping to take nitrogen out of the water that's going downstream in the Great Pond. So if anyone would like to help with the field trips, we welcome you. That would be great. And again, thank you for all our volunteers who have been doing this. Plus, we've had some really great interns who've worked with us too, who've helped us do these projects. So thank you very much. And I'm going to pass this off to Lucy from 300 Committee.
I don't have any pretty pictures, but I'm going to be brief. I wanted to echo what Wendy sort of closed with, and that's improving. Oh, sorry. The river restoration is not only improving the environment and the habitat for the fish and the other wildlife, but it's improving things for the citizens of Falmouth. And so a little bit of the context of the river restoration and the Coonamessett Greenway that the 300 Committee has been involved with really from the very beginning of the 300 Committee. And I'm going to use the abbreviation T3C. It's a little easier to say, fewer syllables, but that's our little acronym. We're really pleased to be a part of the Coonamessett River projects, the restoration and the public access improvements at the river. Since, as I said, 1985-86, when the 300 Committee first started, we've worked with the town to permanently protect lands all along the river. And the Coonamessett Greenway, as it exists now, is more than 280 acres of contiguous, permanently protected land owned by both the town and the 300 Committee. One of the most recent land acquisitions along the river that's a key link in the Greenway are the 46 acres of Andrews Farm and Andrews Grove. This joint purchase by the town and the 300 Committee for $2.95 million, most of which was privately raised, received unanimous vote of support at the April 2017 special town meeting, just a few months before Phase 1 of the restoration project actually broke ground. Well before the acquisition, as you've heard, the plans were underway to conduct the river restoration and to start fleshing out the details of the Coonamessett Greenway Heritage Trail. Public access to conservation lands is intrinsic to our mission, and the creation of accessible trails has been a major initiative of ours since about 2010. And the first accessible trail, fully accessible, wheelchair accessible trail we created, fundraised for, and installed was at the Bartolome Conservation Area, which is actually now part of the Greenway. It's just north of Andrews Grove along Pond 14. Since that first accessible trail project, the T3C has created other accessible trails, all of the streetscape trails at T-Ticket Park, and the Jeffress Williams pathway at Two Ponds Conservation Area on Gifford Street. As part of the Coonamessett Greenway Heritage Trail project, we were thrilled to support the creation of the fully, as Betsy mentioned, the fully accessible trailhead parking and lower river loop trail, which is a full mile of accessible trail, which includes the 2 boardwalk river crossings and the parking area and the zigzagging trail that comes down from the parking lot to the riverway. In November 2019, we donated $295,000 to the town in privately raised funds to make these public access improvements possible. And lots of people we know are enjoying not only the lower river loop and the overlook and the gateway to the Greenway, but also all of the linked trails along both sides of the river. We've been involved in bringing people to the river since the beginning of the restoration work, even before that, but predominantly more and more focus now since the restoration has been completed at the lower river. So over the last 5+ years, our outreach committee members and walk leaders have led, I don't know, I lost count, several dozen walks, not only to the lower river conservation lands, but to all of the linked parcels along the Greenway, Andrews Farm, Andrews Grove, Bartolome, Riverbend, etc. And then, of course, further north to Matt Souza Conservation Area, George Souza Preserve, Toner parcels, and more. And those parcels I just discussed are among those that are slated for future restoration. Thanks, sorry. Our primary goals have been to introduce people to this amazing area and the incredible work that's been done, incredible and very, very important work, to highlight the habitat restoration and its many benefits. And of course, to share the special, rich, natural and human history of the whole river corridor. We've helped hundreds of people discover this amazing place, and we plan to lead more hikes in the future. COVID has been really good for getting people out and introducing people to these paths, and so many people, so many citizens of town, so many visitors have come to appreciate more and more the recreational opportunities, not just along Coonamessett River, but all over town. And we're really, really pleased about that. We're really looking forward to continuing our collaboration with the town on the next phase of the restoration and public access projects. Hopefully they will move forward. And this is especially exciting to us as we anticipate during the next year or so moving our headquarters to right near the Coonamessett Greenway. So, thanks. I think
Thanks. I'm going to ask you, who offered to help, could you put the microphone out there? And let's have about, well, if there are questions. Does anybody have a question about any of the talks that have been given? Maybe there aren't. Everybody was.
I have a trivial question. What happened to all those plastic eggs?
They got collected and they got used the next year. That's it. I can answer that. All right, well, we're almost ready for Nick. I just want to put it's obvious, I'm sure, to all of you how much effort was put in by so many of the volunteers, and I can also say by the people who work for the town of Falmouth. This was a town of Falmouth project. But there are lots of ways for everybody to volunteer. Everybody has different talents. And even something as simple, I said to a friend who brings his classes out for his hiking club from one of the schools in town. He goes out to the gateway, and I said, hey, I said, you know, you could bring along plastic bags. And anytime you go to any trailhead, you can have the kids clean up the trailhead. And the next time I saw him, I see him in the gym regularly, he said, what a good idea. The kids love it. And I said, well, I said, I do too, because I would rather not have to do it when I go out. So there are all different ways people can contribute. But I just want to say, I really appreciate that, you know, these couldn't be done at this scale without all the federal and state funds, but they really couldn't be done, or they wouldn't be worth being done unless it was a joint effort of everybody in town. And it's been, personally, it's been a pleasure to work. That's one of the, well, the best thing is to work with second graders. But next to that are all the other people I've gotten to work with, one of whom is Nick Nelson, who's our, most of you knew or know Frank Duffy. I just remember going into Frank's office to get a signed contract that he had to look over, and he says, I just found out, I had to look it up, what a fluvial geomorphologist was. Well, here's our local fluvial geomorphologist to tell you about the upper river.
Betsy, feel free to get up and stretch your legs and your arms as we get started here. I'm just going to switch out the PowerPoint here. So I know you've been sitting for a while, so feel free to stretch for a minute while we get this up.
Does everybody want to get up and do a jumping jack?
Yeah, there you go.
We'll watch.
Oh, I used to have my high school students do. I'm going to tell you all another story while this is being done. Looking at Steve. Steve doesn't like me to say this, but that little stream where they measured the nitrogen and where the trout go, when we first did that, I said to Steve, I said, yeah, we call this, well, I called it, right, Hurley's Creek. And he said, well, I don't want it called Hurley's Creek if it isn't going to work what it's supposed to work. So then I said to him, a few years later, I said, well, are the trout using it? And he said, yeah. He said, it could have been made a little deeper. Are we set? Okay, we're set.
All right, I think we're set.
Down again.
I'll start it off by saying, you know, Betsy was just saying how much she appreciated all the help that, you know, she's gotten over the years for this and makes these projects work. But these projects really don't happen without somebody like Betsy as well. So it's been amazing to have her kind of shepherd this project through. I think our first contract was in 2010, so we've been involved in this for a long time as well. You got a good introduction on all the work that's been going on throughout the river. I'm going to talk about the Upper Coonamessett project, which is in designs and permitting right now. So just quickly go through. I'll skip through a bunch of these introductory slides because a lot of it's already been said here. But I really want to focus on some of the proposed restoration actions, which are similar to the lower section, but we are in a different portion of the river. There's less water, it's a smaller stream, so there are a few different actions that we'll be taking up there. And then we'll kind of go through what the expected timeline are, and we'll have a chance at the end for some questions and discussion as well. So as with the lower project, there are lots of project partners here, probably more than this list. There will be more that will continue to be added here, but many of the same ones that Betsy was talking about earlier. On December 21st, we held a series of public meetings. One was in person at the Upper Coonamessett River site, and the others were virtual, trying to span the whole day of times when Some people might be more available than others. We had a good showing for the in-person meeting, and then we had one or two show up for each of the virtual sessions as well. So just your overview again, lower Coonamessett River work being done down here. I'm going to focus on the upper Coonamessett headwater bogs up in this area just south of Coonamessett Pond. Similar goals to what were discussed earlier for the lower bog section: pedestrian crossings, reconnecting the river and the floodplain, improved fish passage, native plantings, all of that going on for this site. Some of you who walk around those trails right now might have observed some recent maintenance or tree pruning that's been going on out there. That is part of the DPW maintenance of the site and of those trails. It's not the restoration project yet, so it's not started. Construction hasn't started. We have not gotten through designs and permitting yet. But this coming Friday and then next Friday as well, and Mark will discuss this a bit at the end or be able to answer some questions at the end as well. But there will be some volunteers going to the site to remove some of the invasive plants that are there now. So there'll be a number of people on site cutting down some of the invasive willow trees and saplings and hauling those to the side of the bogs to be chipped up. So that work will be ongoing over the next couple of Fridays. This is just an air photo of the site, and to orient you, I've tilted the aerial photograph so that north is to the right over there, but that's so I can fit the whole thing into one view here in landscape view. So Coonamessett River flows south through here. You can see it coursing through here and leaves our project site right at this location. These bogs have certain names to them, but when we talk to permitters about these projects and we get to construction and contractors, they get a little bit confused about Upper Baptiste, north, middle, and south, and Lower Baptiste, north and south, and things like that. So we try to make it really simple. We go from A to E, starting the upstream end: cell A, cell B, cell C, cell D, and cell E. So we try to simplify things a little bit. If you've walked around this site, you know that there is a dam right at this location. That's the Broad River Dam, and this is called a river, but it's a pretty small stream here, starting right next to the road there, the Hatchville Road. Same view here, but these colors underneath are the thickness and depths of peat underlying the sand in certain portions of this site. So there was some sensors done throughout this area where they could measure the depth of sand and then the depth of peat underneath that as well. And so the colors that are in the sort of blues and purples here, those are the deeper areas of peat. And so you can see these pockets of deeper peat. Elsewhere, there's a couple of feet of peat, but not as deep as we see in some other bog sites in Plymouth or elsewhere on the Cape, and even portions of the lower Coonamessett where we had really deep peat, where we created some of those small ponds over there. But as with the lower Coonamessett, there were portions of the lower Coonamessett River that didn't have much peat either. There are certain elements here that don't have much peat. This is what it looks like right now. Under existing conditions, you see the pitch pines and you see some of the invasive willows growing. There are some red maples growing as well, but there are a lot of those invasive willow trees. And this is the stream, and you can see pretty low flows through here, but that's pretty typical for our natural stream flow in this part of the watershed. We're near the headwaters, a lot of spring flows coming in here, but again, it's at the top end of the watershed, so the discharge or the water flow is a lot lower. And you can get a glimpse of the culvert right there, pretty small culvert, And just like the culverts under John Parker Road previously, they're in pretty poor condition. Another flow control structure here. These are the barriers that Betsy alluded to earlier that we'll attempt to remove. A walking trail here, earthen berm separating the active stream channel over here from the bog surface on the left of that image. And this is the Broad River Dam with the flashboards put in place in that flow control structure. This is, again, one of the bog cells. You can really see over-widened stream here, lots of these invasive willows on either side of the stream channel. And so we'll kind of dive into some of the design elements here. When we begin construction, the easiest way in is through the driveway that you access it now, and that parking lot area will be the primary staging area for construction. As you may have seen with the lower bog restoration, there are lots of big trucks, there's trailers, there's storage boxes, and there needs to be space for the contractors to park every day as well. So that staging area will be really important throughout the construction. And then during the activities, the perimeter dirt roads will be used for the contractors to move around the site and haul materials. This is an overview of the design concepts right now, and we're in preliminary designs right now, about 50% designs. And the site, based on the conditions here and the various elements, sort of split up into 3 different design focus areas. In the upstream bogs here, we're proposing to keep the stream channel in its existing location, but to narrow it up quite a bit and create more sinuosity within the existing channel boundaries. And I'll show you some images of how we might do that. And then in this middle section, in cell C here, or on the edge of cell C and the northern section of cell D, this portion of cell D here is a forested swamp that has pretty good canopy cover overlapping the stream channel. We're going to leave the stream channel in its existing location there, maybe add some large wood for additional habitat complexity, but remove the berm, the earthen berm here, to be able to reconnect that wetland complex, the bog, the former cranberry bog, with the stream channel. The colors that you see here are the cut and fill, areas of cut and fill for excavation. So you'll notice in the table here, the greens, the different shades of green are areas of fill. So you'll see we're proposing to fill the existing channel in certain locations, and the other colors here are areas of cut. So we're removing the berms in certain locations, the earthen berms, cutting a new stream channel in this lower section, and filling the existing channel through that area. And I'll get into each of those sections in a bit more detail here. So if we start at the upstream end in cells A and B, again, this is Coonamessett River flowing downstream in this direction. The proposal here is to remove the earthen berm here, and that's probably the most obvious earthen berm. If you go visit this site, you come right out of the parking lot here, down the trail, and that's the first one you cross over. So we're removing that, but we are adding a stream crossing at the upstream end, so you still have that loop around both of these cells. This berm will be partially removed as well, but a boardwalk or a series of small crossings will allow connectivity there. The proposal is for this loop here to be an all-accessible trail as well. The stream channel at this location, again, as I mentioned, will be a more meandering stream channel, a much narrower stream channel than it is right now. We found that stream form that you see here partially based on what we see in the ditch right now at lower flows. You can kind of see the stream start to meander within this over-widened stream channel. And so we took that approximate plan form and replicated it through this area. Throughout the cranberry bog, outside of the channel, we'll do that microtopography that we did in the lower cranberry bogs, the lower Coonamessett River, and there'll be a small pond here, a little bit of sand removal right at this location. We are not proposing a large amount of sand removal throughout the bog complex here because there's already, it's already fairly wet in these locations. There's a lot of groundwater coming in, based on the current elevations that we have in the stream channel, we don't need to lower that floodplain surface to make it much wetter. Some portions of these perimeter ditches will remain open. That's the purple dashed line here. On recommendation from Steve Hurley and based on the groundwater that's coming in here, idea is to maintain that cold water that's coming in through those sections. And so this is a typical detail kind of showing the proposed channel in that location. The way we're going to narrow that stream channel, you can see the sort of existing stream channel being this boundary along the edge here. And we'll narrow that by bringing some, cutting out these pools in the outer bends and putting that sand on the inside of the meander bend, bringing some of the pine tree saplings that you see growing out there. Those will be pulled out of the ground and be used for large woody habitat here. And then the proposal also is to grab, with the excavator, grab scoopfuls of the vegetative mat on the cranberry bog and place them on top of this bar, essentially, to get that vegetation growing right away. And so we're essentially creating this little meandering stream here using existing materials that we can have right there. So we're not importing much in the way of materials here. These larger logs with root wads to provide additional habitat, those are going to be imported. But all of these smaller saplings will be just from the existing pitch pine trees that are there. Moving downstream into cells C and D, again, the Coonamessett River is flowing adjacent to this earthen berm right here. Downstream, we've got the Broad River Dam right here, and then we have this really wide section as it moves downstream in that location. So for these two bogs, as I mentioned in the overview, the earthen berm that you walk down to connect through here will be entirely removed, and this berm as well, and the berm that crosses where the Broad River Dam is right now will be removed. Access will be retained around the perimeter, while it will be an all-accessible trail in the upper bogs, cells A and B, be just pedestrian trails down in this area and crossing the Broad River once that dam is gone, and then all the way around the perimeter again through there. Again, no stream modifications to the Coonamessett River in this section, except for a few locations where we'll be installing complexes of those pine tree saplings for additional habitat. And then as we move into this, this lower bog here, cell D, you can see a new meandering stream channel. This is where you see a lot of the 20 to 30 foot invasive willow saplings through here. There are a few maples and a few birches in there, but mostly those invasive willows. We'll be reconstructing a new meandering stream channel, again, much narrower than this over-widened system here. This will get filled in, except for a small section here, which will be an open water pond for dabbling ducks and other organisms there, other creatures and plants. And then cold water coming in from the ditches along the edges once again. The culvert underneath this berm between cells D and E will be replaced with an open bottom crossing there to provide additional crossing habitat for fish and other mammals and turtles and other organisms that prefer to go underneath the bridge than trying to hop up and over. Look at some of the typical details again. This is in that section where we're not changing where the stream channel is, but we're adding these clusters of large wood here. When you walk this section right now, when you see a a tree that's fallen in or a root wad that is kind of sticking into the stream channel and it narrows the stream channel, that's where we see the water going a little bit quicker. You see some of the gravel and coarser substrate revealed down there, and it provides a little bit more habitat complexity. And then these are the details for the new meandering stream channel. So importing some of those large wood logs and root wads and also some slash to provide habitat in those pools on the outer bends and provide other habitat throughout. This is similar to what we see in the lower Coonamessett bogs, but not quite to the same extent. Down there at a much larger river, greater discharge, and we also have the, as we learned, some tidal influxes through there. So those pieces of wood are much bigger. They're more heavily engineered to work together as an engineered log jam along those outer banks to provide bank stability. We have a little bit more flexibility up here in terms of our design elements here because there's not as much velocity, not as much flow through this area. And then finally in the lower section, pool cell E, very similar design to cell D with a new reconstructed stream channel and an off-channel open water pond here. This is a shallow pond. Around the perimeter, we're proposing to place salvage sphagnum moss, which we've done in some bogs in Plymouth, where the contractor will scoop up sphagnum moss from the existing ditches around these bogs and place them along the edges of these ponds. And that sphagnum grows pretty well along those edges and develops this floating bog mat out there. And it's really fun to see that develop with the cranberries still growing on those vegetative mats, the sphagnum growing, small shrubs even growing out in that kind of floating bog out there. And then similar designs for the stream channel there. So you've seen the evolution of the lower bog system. You've seen it go from this, where it looks like a moonscape, and we saw comments about that on the whiteboards out there, to a fairly complex ecosystem that you've heard lots about today already, so I'm not going to focus on that. Lots of fish in there. I did want to touch on these vertical posts that you see out here in the lower Coonamessett River. We call those timber piles or timber posts. Those are really critical to the designs for the lower Coonamessett bogs to help hold all those wood pieces in place. So those are intermixed with the horizontal logs and root wads that are stuck into the banks. They help hold all of that together, and they also provide additional complex habitat. We've seen woodpeckers burrow into these. I've stumbled upon a bee's nest in one of those, and that they provide bird perches as well. So they serve a number of purposes. For the upper Coonamessett bogs, we may have a few of these in there, so you might see those scattered about, but they're not as critical of a design element because we don't have that potential for additional force and higher shear stress or flooding that we might experience down in this area. One thing that we do have to be aware of for some of the lower sections of our new restoration site is the continued cranberry production in the adjacent bogs, which will be continuing. And so the farmers there will need to flood the bogs to push water into their bogs. So when we're designing this next phase of design, when we're thinking about these large wood complexes, we do need to be thinking about buoyancy for that large wood with that in mind. So I'll just quickly flip through this since you've seen it, but over time those vertical timber posts, you can kind of hardly see them as they poke out through the vegetation that's growing out there. A couple pictures of the site that was the earliest cranberry bog restoration, finished in 2009, 2010. This is the Eel River in Plymouth. Prior to restoration, looks similar to the Coonamessett River before restoration. Ditches, cranberry mats out here with some other vegetation popping up. But very quickly, over a decade or so, we start to see a real evolution of the whole site. And here It's pretty special to walk through here and see the sphagnum moss has developed into 10 to 12 inches thick of sphagnum, which is actively developing peat. And we also see the Atlantic white cedar trees that were planted at about 3 feet tall are now over 20 feet tall, and they're producing their own young, which are, tiny, up to 3 to 5 to 7 feet on their own after several years of growing. So that's exciting to see. The next steps here, as I mentioned, the next couple of Fridays, there'll be some volunteers out on site removing invasive plants. This year, we're going to focus on additional designs and permitting. So we're beginning that permitting process now. And then hopefully towards the end of this year, we might be able to begin construction, and certainly into next year. And after that, the continued monitoring that you heard earlier today will hopefully continue beyond that point. So I'll end there. I wanted to open it to Mark to see if you wanted to mention anything else about the invasive plant removal this Friday. Is there anything else you wanted to say there, Mark?
Pretty much summed it up. I mean, we're gonna have a bunch of volunteers out there from Miracle and Upper Cape Tech, just found out. So we have a committee volunteers. The Coonamessett River Trust.
Great. Thank you. So I'll open it up to questions now. Questions about the restoration elements, questions about the invasive removal or anything else you might have. And I think if you could come on up to the microphone here, that would be best for those viewing.
Thanks. You mentioned a lot about the invasive. Even if it wasn't on, I think I'm speaking loudly. So he's talked a lot about the invasive willow and their removal, but I haven't heard anything about the Russian olive that's really invasive and widespread in that area. I don't know if there are plans for that or.
Yeah, really good question. So the question is about the other invasives that are out there, and there's Phragmites, and there's probably some knotweed. You got the whole slew of them. So the hope here, since the willows are so pervasive right now and they're getting towards tree form, the hope is to knock those back as much as we can prior to construction, to give the contractor a little bit of a jump start so they're not dealing with acres and acres of invasive plants to remove. But as part of the contract documents that the construction contractor will receive, they will have to put together invasive plant management plan, which will be tied to about 3 years of planting warranty and maintenance for the site. So as we did with the lower Coonamessett River and other projects, there'll be a warranty on the plants that they put out there, but they also have to provide an invasive-free site for those 3 years after construction. So they'll manage that for each of the species of invasives as required, so including Russian olive and the others. Any other questions? So another one? Oh, yeah.
Hey, Nick. So I was actually wondering about monitoring and whether or not there's going to be any water quality monitoring for the upper Coonamessett. And I'm curious because, and correct me if I'm wrong, Chris, that the water quality, the nitrogen budget that you have, we don't know what the nitrogen budget was while it was a bog, or excuse me, as a cranberry farm. So I'm wondering if this is an opportunity to learn a little bit more about that budget on the upper part and then see how it, responds afterwards. I don't know if that's been thought at all coming
Chris,
up
do you wanna
for this next
speak to that?
phase.
Yeah, sure. So that's true. It is an opportunity because we've been monitoring that since 2018. We don't. It'll take a little bit of funding to do that, but not a huge amount. The Coonamessett River Trust would love to be involved in continuing that. and we're trying to continue it best we can right now. I will say that the nitrogen, the incoming nitrogen, like Broad River has very little nitrogen coming in. The upper river system has very little nitrogen coming in. So I wouldn't expect big changes with restoration because the inputs are already low. That upper part of the river is very clean compared with the lower part. So I think it's worth doing, but I wouldn't expect a large change in. And the flow is about less than a tenth. Say it's 300 liters per second at the bottom. It's maybe 15 liters per second up at the top there. So it's very low flow. So even if the concentration was higher, the flow is so low that it's not a lot of nitrogen being contributed to the rest of the river from that section. I guess that's just the perspective on the overall budget.
Thanks, Chris. Did you have a question as well?
Yes, there's some cranberry growers just downstream of these upper bogs. And I was just wondering what kinds of responses you've had. I know that they want water at various times of the year, and there was some initial discussions about kind of how that water would be supplied in regards to these mitigation projects and whether there was something that could help to mitigate their water use in that area. Have you been involved with that at all? Can you speak on that?
Yeah, good question. We walked the site and went to that location with the farmer and the landowner. And so just for orientation, this is cell E, the downstream bog cell that we're working on. This location here is the outlet of the existing stream channel. There's some flashboards in there that they put in to flood the bogs. And Augusta Bog, spelled improperly there, apologize, is over here. And then there's also the Adams Bog downstream. This part is not farmed, but there's bog over here that is farmed. And there's another flow control structure over here that they use to help flood the Adams Bog over here as well. So we had some discussions with the farmer on site, and we talked about the restoration that was being proposed and how we might be able to work with that. And we were trying to come up with other supplies of water for them to use. But really, it came down to they don't really see another option for providing the supply of water that they need for their bogs, for flooding their bogs, anything else aside from the river. And so what the plan is currently is to keep this flow control structure in place, but as they do now, the farmers will remove the boards for fish passage during certain times of year. And actually, they only flood the bogs for a certain period for harvesting in the fall, and as you all know, for flooding in the winter. So not the times of year when the fish are migrating. There's continual discussions, I believe, between them and the folks in town focused on monitoring the fish and herring wardens and all those folks. But the goal in talking to the farmer would be to clear out the ditch that's along here, which is where the water goes in order to go into the Augusta Bog right there. So to make that more efficient, so that water can get into that pipe a bit more efficiently. But right now we are anticipating that this bog and likely cell D as well will be inundated for those times of year that they're currently inundated. And after some, reviewing of the site conditions, we see wetland conditions being successful out there. We see wetland plants growing right now. So that's how we anticipate moving forwards as well with these designs. Certainly from an ecological standpoint, it would be nice to remove all the culverts, as we talked about before. But we currently get fish passage through here with the boards removed. There's currently wetland functions happening out there. So the goal would be to improve all of that through these actions, but we'll be kind of still having that inundation at those certain times of year. Good question. Any other questions? Yeah.
So on cells D and E there, where you're completely changing the path of the river, I'm just wondering if you could talk a little bit about how the decision is made to where that new river goes. Is it based on where you think it used to go, or the geology of the area, or just trying to make it as long as possible? Or?
Yeah, no, really good question. And it's a bit of sort of forensic geomorphology in a way, but also some constructability issues during construction. So it's really hard to know where the original channel was in these systems because they've been so manipulated over time. But we generally see that we come up with these plan forms based on some lesser impacted rivers in the area that we can look at the channel sinuosity, or even peat swamplands elsewhere in the region where we can kind of see some of this sinuosity. We are also trying to place the new channel in the general low portion of the valley. As you know, these cranberry bogs are fairly flat, but there are some subtle differences from the edges of the bogs towards the middle. So we don't necessarily want to put the channel on the edge in all locations if it's lower in the middle, because then it might slide off of that channel and get back into the middle where, gravitationally it wants to go. So we're trying to get it in the low portion of the valley, but also we don't want to build it too close to the existing channel all the time, because then it becomes really hard to construct. It's really mushy over here, and it's hard to separate the existing channel from the new channel in those locations. Similarly, we don't want to keep crossing over the existing channel because, again, water control issues during construction are really hard. So all of those play into it. We also looked at the peat depths and thicknesses underneath, thinking that historically, some of those areas of deeper peat were likely where there was water, prior to the peat also, and sort of those low areas in the valley. So a number of things kind of go into it, both from the practical standpoint, but also the science part of it. Any other questions?
What sort of permitting, town permitting is required?
Yeah, great question. So there are lots of permits that are required for restoration projects, town, state, and federal. And so the general process is to go through, what first is it's called the MEPA permit or notification form. That's a state-based one, Massachusetts Environmental Policy Act, environmental notification form. And that's sort of a general notification of activities that will have impact on resources that are protected by the state. So we're sort of starting that process right now with MEPA. But after that comes all the other permits, which include DEP 401 water quality certification. There's also the DEP Chapter 91 dredge permit and a Chapter 91 license for any stream crossings that are being built across the river. The Town Conservation Commission notice of intent, so that'll go through the Conservation Commission, and then ultimately it also goes to DEP, but that the Wetlands Protection Act is guided by the Conservation Commissions first, and then DEP as needed beyond that. And then there's the U.S. Army Corps of Engineers 404 dredge permit as well. And with that, there is historical and archaeological coordination and federally endangered species coordination as well. That answer okay?
What about, is zoning involved in this at all, town zoning?
Zoning is notified, so as part of those permits, multiple agencies within the town are notified about the project. The zoning board, the select board, health boards, there's many others as well. They're all notified. It's not a change in zone, so we typically haven't had any comments from the zoning departments in town here or in other towns that we've done this. Trying to think what else. Sometimes there's a local building permit when you're doing the stream crossings. And in some towns there are, town-specific bylaws that might be more stringent in the wetlands protection than the state laws or the federal laws. So sometimes there are town-specific things to be focused on. But for the most part, the MEPA process notifies a lot of those town groups, and then the DEP permits and the conservation permit as well. Those different entities are notified as well, and have to sign off on it. There's a couple of them that have to sign off on one of the DEP permits. Any other questions? Yeah.
There seems to be,
You can raise that up if you want.
seems to be area between the two projects or the three projects, so you can't really see on the map.
Yeah.
And I'm wondering if there's ever going to be a connection, or is it privately owned, or?
Yeah,
I
good.
thought there was a pond somewhere.
Yep,
There's
yeah,
been
I
no
don't have an
mention.
image. Oh, maybe I'll go all the way back. Yeah. All right. So there's a gap. You've identified the gap. And Betsy, I might need your help here, but this is where we're working here. There are active cranberry bogs here, and I believe a little bit scattered throughout here. Pond 14, I think might be the pond that you're referring to. That's the pond right here, which is just upstream of the lower Coonamessett bog restoration that happened. There's a bypass channel that goes around the dam there, and then I think the publicly accessible place is right over there that was referred to. I believe there are some stopping points along the greenway connecting. Do you want to expand on is there walking trails through there right now, or interpretive signage, or what's the connection between where we are and Pond 14?
Yeah, so, yeah, the I don't know exactly, I don't know exactly the direction of your question, but the Coonamessett Greenway Heritage Trail extends all the way from the lower part of the river all the way to the Coonamessett Pond, and there are kind of multiple loops. There are, we're hoping our 300 committee partner can work with us. There's only one gap. All the rest of the river is bordered on both sides by conservation land. There's one little gap that's private, and they're very diligent on targeting these areas, and should it become available, they'll either purchase it or they'll work with the town to purchase it. The fish go all the way up the river now. It takes about, I think the fastest is 5 hours. A fish can make it up in 5 hours. Some fish don't make it up at all when they had to go through these barriers. But when we finished this project, it opened up a free-running stream for 2.2 miles, and the area where we're working now is at that area, because in less than half a mile stream, there are 7 culverts that the fish have to go through. So that's why we're targeting this upper Coonamessett area next. Once those are eliminated, basically there's a passage all the way up. Pond 14, there is a bypass to Pond 14, which is a cold water bypass. But some of the fish go through Pond 14, and you know that there's if you've been out there, a fish ladder. Yeah. And we're not going to talk about, because we have no plans now about any other restoration parts of the river. But at some point, there could be further work.
I think the two areas that, were worked on previously and working on now, those are the areas with the most extensive public access on either side of the stream channel. There are more private entities nearby through here, so we don't have as much sort of free reign to wander around the valley floor in those areas, but there is that access now.
Right. Yeah, that's fine. That's part of the river is fine there. If you're not familiar with the trail maps, you can find them on the 300 Committee website. And there are trail maps all the way along the trail also.
I'm just wondering about the lower bogs and how they've been done. We're so lucky to have them. And I'm just concerned that overall management, and we live in a very challenging world where certain people have no respect for the environment. And we have a couple of spots where there's a log that's 20 feet long that's been dragged out onto the pathway currently right now between Dexter and Swift's Bridge. It's on the left-hand trail, and it's very big. It can't be moved. There was 4 other pieces. Someone actually probably took them and put them back where they were. And also in that particular area, there's a tremendous amount of, because they're out there in the rain, 4-wheel drive ATVs coming down the hill. That's who moved those trunks, I'm sure. And I was wondering, is there any number that we could call? Because there's also 2 dumping spots, one right at the bridge on the left side, which I don't know if you've noticed, but we have a lot of rubbish, pieces of tree branches and top, and also further down just as you're going down further, there's a tremendous area of cans and metal waste that have been dumped in where the poison ivy bed is. If you're familiar with that poison ivy bed. But I'm just wondering, that I don't want to see that we're getting all this beautiful stuff done. You've worked so hard. Do we have any recourse, or do we have any place to call while going in there with a chainsaw to move that log? Because it is actually blocking
I know,
the road.
I've been there. So
Yeah.
I can answer that.
Okay, thanks.
First of all, let me thank the DPW, in particular, well, let's start with Mark. Mark is our land manager. And so if there are issues like that, you can leave a comment with, or write to Concom. And Mark and I will both end up seeing that. There's a perception in town among some of the people that anything that has to be done, ask Betsy and she'll get it done. But anybody who's worked with me knows that I can't actually do anything. All I can do is find somebody who can do it. So it's especially the Jim Grady's Highway Department and Jeremiah Pearson's Park Department have been invaluable in doing this. And so, but I must say, when there are issues, I'll talk to Jim and Jeremiah, Mark and Chris, who's in engineering. They can't always get to it right away. And I'll tell them what the problem is, and I'll say, when you can get to it. However, when there's something that I consider is, has to be done in a timely way, I'll write an email and it's done the next day. I'll go in to see Jim Grady and he says, oh, I'm crossing it off. The person I sent has already been out there. So, yeah, so let us know when there are issues. Also, as people can clean up on their own, we appreciate it. But
I think people have tried, but
it is, I saw that, and I don't know whether Mark knows about it. Yeah, I haven't told Mark about it, but I just saw it either yesterday or the day before.
Because it does block the trail for also strollers, also if there's anyone with disability, even for any of us that have to, climb over.
Right.
That's pretty big.
Right.
But that log was dragged out, and that was blocking that, that egress.
Well, those ATVs,
Four-wheel drive ATV.
yeah, it's,
Down there, you can probably catch
It's a problem. It wouldn't hurt, I'm gonna just throw out, to call the police department too and ask about it. Maybe if they have a number of calls, they might take it more seriously.
Something that we have to be aware of because, you know, it becomes a track.
Yeah, there has been, thankfully, there hasn't been that much vandalism, but there has been some vandalism, and the town has responded to it in a very timely manner. But thanks for bringing it up, and also, I know all of you are conscientious about keeping things looking neat and functioning, but, you know, don't, don't hesitate to pull other people into the projects as well. Thanks very much.